On the 20th of July, 1969, inside a lunar module standing on the surface of the moon, an astronaut reached out and pressed a key marked Verb. The letters on that keycap were not printed. They were cut. Carved into the plastic by a machine descended from a design built inside a backyard greenhouse in Racine, Wisconsin. That was 1969. 5 years later, the company that built those machines was padlocked, its factory floor swept bare, and hundreds of its toolmakers were standing in a Wisconsin parking lot with nowhere left to go. But this story does not begin with Apollo. It begins in a cotton town in Lancashire, England, in the year 1825. You are watching Trade Archive. His name was William Buffum. Born in London in 1801, he moved north to Rochdale as a young man, into a town of mills and soot and mechanics. Around 1825, in a workshop there, Buffum built a machine for engraving medallions. Not a press, not a die, but a machine that could trace a large master shape with a stylus and reproduce it in miniature on metal, over and over, by mechanical linkage alone. By 1842, he was building microscopes and telescopes, work that punishes anything less than absolute precision. In 1850, he packed up his wife and 6 children and sailed for America, settling eventually on a farm in Millburn, Illinois, where he kept grinding lenses in a shop behind the house. He died in Racine in 1871. He left behind a set of hand-cut taps, dated 1845, made in Rochdale. Those taps stayed in the family, and nearly 70 years later, they were photographed for a National Machinist trade journal as an example of what English handwork could do before machine tools were themselves machine-made. Buffum's daughters married into a family called Gorton. George Gorton, the first of that name in Racine, had come from Rochdale himself, arriving in Wisconsin in 1845 and opening the city's first drugstore the following year. He married Anne Buffum. When she died, he married her sister Elizabeth. He was a chemist and a merchant, not a machinist, and there is no evidence he ever touched a lathe in his life. His son was born in Racine on the 5th of February, 1865, weeks before the end of the Civil War. George Gorton II inherited nothing from his father but a business sense and a surname. What he inherited from his mother's side was the thing that mattered. At 9 years old, he built a lathe, a working wooden lathe driven by a windmill, its bearings lubricated with tallow, because that is what a boy in 1874 could get his hands on. A windstorm tore it apart almost immediately after he finished it. He built other things instead. By his late teens, he was teaching mechanical drafting at the Racine YMCA to men older than he was. Then, in 1888, his father died, and the family business landed on him without warning. Racine Basket Manufacturing employed more than 200 people, and Gorton, in his early 20s with no experience running anything, went to work as a salesman for a company he was supposed to be leading. He learned the trade well enough to make it profitable. The moment it was profitable, by his own account, he was maneuvered out of it by a man who wanted the factory for himself. He was 28 years old, unemployed, and $1,000 in debt. In 1893, Gorton went into business with another man pushed out of the basket works, a machinist named Fred Graham. They had no capital and no building. What they had was an unused greenhouse in the Gorton family's backyard, 12 feet by 15, glass walls and a dirt floor. That was the entire plant of the Gorton and Graham Machine Company. Gorton's younger brother Charlie came on as their only other hand. Orders did not come. Within months, both Graham and Charlie left for jobs that actually paid, and Gorton was alone in a greenhouse with a debt and a dead partnership. In 1895, he incorporated the business under his own name and kept going. What kept him alive was abrasive disc grinders, heavy, unglamorous machines for cleaning up castings and forgings, the sort of thing every foundry and forge shop in the Midwest needed. He was good at it. By 1900, he had a 40-page catalog and a bronze medal from the Paris Industrial Exposition for his grinding equipment, which for a man working out of a converted greenhouse 7 years earlier is not a small thing. But the machine that would define the next 70 years came from somewhere else entirely. In 1898, Gorton signed a licensing agreement with Taylor and Hobson of Leicester, England, a firm of optical manufacturers. Taylor and Hobson made camera lenses, and lenses have to be marked. Focal lengths, serial numbers, makers' names, all of it engraved into curved metal barrels in letters small enough to fit and clean enough to read. So they had built their own engraving machines, and they had designed their own alphabet to go with them. Gorton bought the right to build those machines in America. He did not know it, but he had just imported the two things that would outlive him. The machine was a pantograph, and the geometry is simple. 4 arms pinned into a parallelogram, one end anchored, a tracing stylus at one point and a cutting spindle at another. Move the stylus around the edge of a brass template of the letter A, and the spindle carves an A into the workpiece. Shift the clamps that fix the pivots along the arms, and you change the ratio, so a 3-inch master becomes a 1/2 inch engraving, or a 1/4 inch, or smaller. That is the whole trick. A pantograph does not make the operator more accurate. It divides his mistakes down until they disappear. Then, in 1903, at 38, with the business finally standing on its own, George Gorton was told he was dying. The diagnosis was a severe kidney infection. The prognosis was 6 months. Gorton did what a man settling his affairs does. He sold the disc grinder business, the thing he had built the company on, to the Diamond Machine Company of Providence, Rhode Island. He signed it away and waited. He did not die. A change of diet, a year of it, and the infection cleared. Sometime in 1904, he walked back into a shop that no longer had a product because he had sold it. Most men would have called that ruin. Gorton called it an opening. He had the English pantograph license, an inherited talent for engraving that ran back through his mother's family to a workshop in Rochdale, and nothing else to lose. He put everything into the engraving machine. And here is the detail that everyone missed at the time. When he sold his engraving machines, he had to sell his customers the alphabets to go with them. Brass master templates, 1 letter per plate, chrome-plated, sold in sets that could weigh 13 pounds and run from 3/8 of an inch to 3 inches tall. Those letters appear in a Gorton catalog as early as 1902. They had no name. They were listed as standard copies, the way you would list a fitting or a fastener. They were monoline, every stroke the same weight. They had almost no sharp corners because a corner makes a stylus hesitate, and a hesitation shows up in the metal. Slightly wide, slightly plain, slightly childlike in their proportions, and completely legible at sizes where a serif would just fill in with swarf. They were not designed to be beautiful. They were designed to be traced quickly by a tired man at the end of a shift. That alphabet is contemporary with the first modern sans serifs in Europe. It predates Helvetica by more than 50 years. Decades later, Gorton would list it in the catalog as Gorton Normal, alongside condensed and extended, and by then, it was already everywhere. The engraving business grew fast. By 1916, the Racine plant covered 15,000 square feet, with another 60,000 under construction, and 90 people on the payroll. The catalog had gone far beyond nameplates. Gorton's largest engraving machine weighed 20,000 pounds and cut tread patterns directly into rubber tire molds. Another engraved identification marks into steel rolling mill rolls weighing up to 40 tons. He built matrix machines that cut working patterns for typewriter faces and type foundry work, which means that, for a period, machines in Racine were quietly shaping the letters that other people's machines would print. The company also cut the Lord's Prayer inside a circle 1/32 of an inch across, and later on the head of a pin, 5/1000 of an inch, a parlor trick, and an advertisement that nobody in the trade could ignore. Then the war came, and Gorton's machines went to work on something else. During the First World War, the plant built fuse ring routers, machines that cut the spiral powder train grooves into the fuse heads of artillery and shrapnel shells. Get that groove wrong, and the shell detonates at the wrong altitude, or not at all. In 1919, Gorton and an engineer named George Gustafson were granted a United States patent for a machine built specifically for time fuse production. Much of the money from those contracts went to a church. Gorton and his wife Sophie, both active in Racine's First Baptist congregation, pledged $50,000 toward a new building. Construction ran over by $86,000 more, and they covered the whole overrun. The congregation named it Gorton Hall. There was a harder side to him as well. In 1917, the company chased a dispute with a Duluth shipbuilder all the way to the Minnesota Supreme Court over an evidentiary technicality rather than settle it. Generous with a church and unyielding in a courtroom in the same decade. Nothing in a Gorton machine was bought finished. The gray iron castings arrived rough. The dovetail ways, the sliding surfaces a table or a knee rides on, were finished by hand, by men working with scrapers and bluing compound, taking off tenths of a thousandth at a time until the bearing surface showed contact across its whole face. Photographs from the Racine floor in 1942 show scrapers laid out on the benches next to hand-lapped cylindrical standards, the reference cylinders used to prove a surface is actually flat, not display pieces. The working kit. Spindles were ground and lapped. Collets were made in-house to Gorton's own pattern, and the heavier vertical mills used a number 10 brown and sharp taper with a factory drawbar that pulled those collets in. Gorton built the cutter grinders too, because a pantograph is only as good as the single flute cutter turning in it, and a cutter that is not perfectly concentric turns a 2/1000th detail into a smear. The company said flatly, in its own literature, that every machine it produced had been developed inside the Gorton shop. Apprentices were made to write out speed and feed formulas by hand until they could do it from memory. This was a plant that made its own tolerances and then taught men how to hold them. There is a story that survives from that floor about a toolmaker named Albert Marini, who went to Gorton to say he was leaving to open his own shop. A man who had spent years training a machinist would have been within his rights to take that badly. Gorton wished him well and said he would see whether he could send some work his way. Racine ended up thick with skilled trades, and a great deal of that talent had passed through Gorton's building first. That culture is what carried them through what came next, because in 1930, the market for capital equipment simply stopped existing. Machine tool builders do not fail slowly in a depression. They fail all at once, because a machine tool is the easiest purchase in the world to postpone. Orders went to nothing. Sophie Gorton died in October of that year. The company that had survived a founder's death sentence was now facing a market with no floor. In 1932, a visitor walked into the Racine plant with a problem. He needed a faster way to cut molds for die casting and plastics because carving a cavity by hand was slow, skilled work, and the plastics industry wanted cavities faster than toolmakers could make them. Gorton, at 67, in the worst year of the worst economy of his lifetime, put the company's remaining money into the answer. What came out was the die duplicator. A tracer on the table followed the contour of a finished master by hand lever, while the cutter above reproduced that contour in steel at 1:1, not scaled, identical. A mold maker could carve one master in something soft and then cut hardened cavities from it all day. That machine grew into the 8D family, and it put Gorton into the die and mold trade permanently, right before the die and mold trade became the most important industry in America. Because in December 1941, everything the United States needed to fight a war had to be made, and to make it, somebody had to make the machines that made it. Gorton's wartime work comes down to one specific problem. The very small, very accurate turned parts that go into instruments had been a Swiss monopoly for decades, and the reason is a difference in how the machine works. Instead of the tool traveling along a fixed workpiece, the headstock slides, feeding spinning bar stock forward through a guide bushing, while cam-driven tools cut it right at the bushing face. The material is supported at the exact spot it is being cut, so it cannot deflect. That is how you turn apart the diameter of a pencil lead and hold it round. Artillery fuses need those parts. So do torpedo guidance mechanisms, aircraft instruments, and bomb sights. And in 1942, the three Swiss firms that built those machines were on the far side of an ocean the Axis controlled. The War Production Board's answer was to copy them. City Electric was assigned the Beckler A-10, Gibbs took the Tornos R-10, and the George Gorton Machine Company of Racine was handed the Peterman P-7 and told to reproduce it closely enough that the parts would interchange. Several hundred were built. Operators later grumbled that wartime material substitutions meant the American copies never quite equaled the Swiss originals, which is probably fair and entirely beside the point. The machines ran, the parts came out, and the fuses worked. For that work, Gorton received the Army-Navy E Award for Excellence in War Production. More than 85,000 American facilities contributed to the war effort. Fewer than 4,300 of them got the E, around 1 in 20. If you are still with us this far in, subscribe. Trade Archive covers the machine shops and manufacturers that history has quietly written out, and there are a lot of them left. By February of 1946, the pennant was still hanging and the mood on the floor had completely changed. Wartime overtime had vanished with the war. Peacetime inflation had not. Across Racine, a union town with deep roots in the machinists and auto workers locals, the same men who had been photographed for war bond drives were now organizing. On the 16th of February, 1946, the Racine Journal-Times reported that 75 tool and die makers had struck 8 of the city's job shops. Members of International Association of Machinists Lodge 437 set up picket lines. Among the 8 companies named was the George Gorton Machine Company. 18 months earlier, management had stood in that plant and accepted a flag from the United States Navy for what those men had built. Now those same men were standing outside it in a Wisconsin February over wages. Nobody in the story was being unreasonable. That is what makes it worth telling. The strike settled. What followed was the best 20 years the company ever had. The post-war catalog is the one collector's chase. The 8D and 8.5D vertical mills, compact and built for small cutters at high speed. The 9J, over 3,000 pounds of iron, configured for duplicating and fitted with power spindle feeds for boring. The 122 master mill, with anti-backlash nuts on the crossfeed screws so a man could climb mill without the table snatching, and an optional hydraulic tracer called the Trace Master that let the machine follow a master pattern on its own. That last one matters more than it sounds. A hydraulic tracer is the missing link between a man turning hand wheels and a computer reading a tape. The pantographs kept getting bigger. A P23 weighed roughly 2,700 pounds, reduced from 1/2 down to 1/8, and ran spindle speeds from 1,300 to 13,000 revolutions per minute on rope belts and stepped pulleys. And the work got stranger. Gorton built super-precision lathes on special order for the Hanford plutonium works, machines intended for glovebox use, cutting weapon cores, specified for low micro-inch surface finish. In 1960, the Journal-Times reported that Gorton had built an automated line to manufacture receivers for the M14 rifle. The founder did not live to see most of it. George Gorton II died in 1955, at 90. He had gone from a wooden lathe in a backyard to machines that cut the cores of nuclear weapons, having been told, 5 decades earlier, that he had 6 months. His sons took over. And the alphabet he had licensed from a lens maker in Leicester kept going without any of them. Because by the 1950s and 60s, Gorton Normal had escaped. Kufel and Esser adapted the pantograph principle into the Leroy lettering set, the template and scriber that every drafting room in America used, and the shapes went with it. The same letter forms fed into technical lettering standards, into the routed wooden signs of the National Park Service, into the vector fonts that would later be built into computer-aided design software. In 1968, The Department of Defense made it official, standardizing the Gorton letter form for markings on military aircraft and equipment dials under its own military specification. And in the mid-1960s, engineers at MIT working on the guidance computer for Apollo drew up the keyboard, the display and keyboard unit they called the DSKY. The drawings specify the font for the keycap legends: Gorton Normal, the annunciator panel, Gorton Condensed. Those legends could not be printed because printing rubs off, and a switch legend that rubs off in flight is a hazard, so they were cut, which is how an alphabet designed to be traced by hand on an engraving machine in Wisconsin ended up under an astronaut's glove on the surface of the moon. The company that gave it its name had 2 years left as an independent business. By the mid-1960s, Gorton was doing about $8.5 million a year in sales, employed 325 people across 2 plants on Racine Street, and shipped 92% of its output outside Wisconsin. Healthy numbers, and not enough, because the industry was moving toward numerical control, and numerical control took capital and electronics expertise a family firm in Racine did not have. In April of 1967, after 74 years, the family sold. The buyer was Kearney and Trecker of Milwaukee in an all-stock deal worth around $7 million. On paper, this was the rescue. Gorton became the Gorton Machine Corporation, a wholly owned division. George Gorton III kept running it and took a seat on the Kearney and Trecker board. That June, the board approved the purchase of 62 acres on Highway 11 for a modern plant, and at the groundbreaking, the founder's son turned the first shovel of dirt with a silver spade. In 1968, they printed a booklet for the 75th anniversary and threw an open house. In March of 1969, 4 months before Apollo 11, the division introduced a 3-axis numerically controlled machining center called the Tape Master. Everything looked like continuation. It was closer to a hospice. The American machine tool industry in the 1970s was walking into a wall. Japanese, German, and Swiss builders moved to computer numerical control faster and cheaper, and American builders, carrying older plants and heavier labor costs, could not follow at the same speed. Kearney and Trecker had bought a division full of superb manual machines at the precise moment the world stopped wanting superb manual machines. In April of 1971, the Racine plant shut for 2 weeks. 180 plant workers and 100 office staff went home. On the 14th of March, 1972, George Gorton III retired at 70. For the first time since a 28-year-old set up shop in a greenhouse in 1893, there was no Gorton working at Gorton. By then, the division was reportedly losing around $2 million a year. In August of 1974, Kearney and Trecker closed it. 7 years after the sale that was supposed to save it, the plant that had produced the tire mold engravers, the fuse routers, the Swiss screw machine copies, the Hanford lathes, and the alphabet on the moon was finished. The Journal Times ran it on the front page. Kearney and Trecker did not outrun it either. They merged with the Cross Company in 1979, were bought by Giddings and Lewis in 1991, and were eventually absorbed by a German conglomerate. Machine Tools built the American Century, and then American machine tool builders were sold to the people who had beaten them. That should have been the end. It was not. Within months of the closure, a longtime Gorton employee named Chuck Larson started a company called Lars Machine, staffed largely with men laid off from the Racine plant, and simply kept building the pantographs and the cutter grinders. The drawings still existed. The knowledge was in the hands of the men who had been let go, and they were not interested in letting it die. In 1987, the Famco Machine Division of Kenosha, Wisconsin, a builder of arbor presses and mechanical shears in business since 1927, bought both the Gorton machine tool line and the Lars products, and moved production into its own plant. In 1994, the assets changed hands again when a buyer took the whole of the Famco, Gorton, and Lars holdings outright. Through all of it, a successor firm called Gormick Products operated out of Racine, and its treasurer was Richard Gorton, great-grandson of the man with the greenhouse. He has described himself as the last of his family to guide the business. They take in Gorton machines that are 60 and 70 years old and rebuild them back to new machine tolerances. Ways reground or rescraped, spindles rebuilt, screws and nuts replaced, the whole geometry brought back to the numbers printed in a catalog when Eisenhower was president. Gorton engraving cutters, brass character sets, collets, and drive belts are still being supplied. Some of the Swiss-type screw machines Gorton built during the war were still running production parts in that shop half a century after they were delivered. That is a strange kind of immortality for a company that has been legally dead since 1974. In the 1970s, a keycap manufacturer called Comptech needed a typeface that could be double-shot injection molded, where the legend is a separate piece of plastic running all the way through the key rather than a coating on top. They took Gorton and modified it, which is why, if you used an Apple II, a BBC Micro, a Compaq Portable, a DEC terminal, or a controlled data supercomputer, your fingers were on Gorton. Comptech's successor, Signature Plastics, still uses that typeface on mechanical keyboard keycaps today, and there is an entire community of enthusiasts who love those letter forms without any idea where they came from. For most of the last century, nobody did. The font had no designer credit, no foundry, no release date, and no name at all for its first several decades of existence. It was a spare part. You ordered it the way you ordered a belt or a collet. The military nearly let it go. The specification that had standardized those letter forms on aircraft dials since 1968 was canceled in 1998, in a general purge of old standards, on the reasonable-sounding theory that nobody needed a government document to describe an alphabet. 9 years later, in 2007, the Department of Defense reinstated it. Something in the world of instrument panels and cockpit markings still required those exact shapes, and there was no substitute that did the job as well. The rediscovery came largely through the work of one researcher. The typographer Marcin Witchery spent years chasing it backward. He started where most people encounter it without knowing, on the legends of mechanical keyboard keycaps, and worked upstream. Keycaps to Comptech. Comptech to military dial specifications. The specifications to park signs and drafting templates. All of it back to the Racine catalogs, and then across the Atlantic to a lens works in Leicester that had drawn an alphabet purely so it could label its own products. The typeface people assumed was a mid-century contemporary of Helvetica was already old when Helvetica was born. It is roughly as old as the first modern sans serifs in Europe, and it has been in continuous industrial use, without interruption and largely without credit, for more than 130 years. Richard Gorton's part in this is almost as unlikely. By his own account, he came to the family history sideways, searching his own surname in a patent database and finding a wall of results he could not explain. What followed was 2 decades of assembling catalogs, serial number lists, photographs, correspondence, and Journal Times clippings into a public archive of a company that no longer exists. Between that, the Wisconsin Archive holdings at Parkside, and the volunteer scanning done by machinists on sites like Vintage Machinery, the paper record of Gorton is in better shape today than it was the day the plant closed. There is no monument to George Gorton in Racine. There is something better, which is that his machines are still cutting metal. A Gorton P23 pantograph weighs about as much as a small car, and there are independent watchmakers who will not use anything else for profiling stainless steel cases and cutting the patterns for engine turning. Custom knife makers use them for shield inlays. Jewelers use them for deep engraving. There is a small but real economy in parts nobody has manufactured in 50 years. Getting one is its own ordeal. A 9J will not fit through a residential door in one piece, so owners strip the head, the knee, and the table, roll the base in on steel pipe, and rebuild the machine inside the garage it will spend the rest of its life in. Some pour a concrete pad first. Then comes the part that would be familiar to anyone who worked in Racine in 1942, because the ways get scraped by hand, with a scraper and bluing, until the contact pattern comes back. The same operation, done by an amateur in a suburb in the 2020s, on a machine finished the same way by a paid toolmaker 80 years earlier. The last step is electrical. These machines were built for three-phase factory power that does not exist in a house, so owners wire the spindle motors to variable frequency drives, and a machine designed for the 1950s production floor runs on the same service as a clothes dryer. None of this makes economic sense. A modern import mill costs less than the rigging bill. People do it anyway, because the old machine holds a tolerance the new one does not, and because there is a specific satisfaction in a tool that was overbuilt on purpose by someone who assumed it would outlive him. One line from an owner's forum sums up the whole culture. Gorton owners are an exclusive bunch who just smile knowingly when the Bridgeport people start talking. If you want another story about an American manufacturer whose product outlived the company that made it, the next one is on screen now. And subscribe to Trade Archive, because these companies do not get documentaries made about them anywhere else.